This is a revision video about the AQA A-level chemistry topic of the chlorination of alkanes. In order to discuss chlorination, we first need to know what a free radical is. So this could be an atom or a molecule or an ion, but the important thing is that it has at least one unpaired electron in its highest energy level. So this is going to make it very unstable, very short-lived and highly reactive. When we're drawing free radicals or writing about them in symbol equations, we show this by doing a single dot to represent that unpaired electron. The classic example of chlorination is the reaction of methane with chlorine, and depending on which of the reactants is in excess, we're going to make slightly different products. So here's methane, which you're very familiar with, and we could make chloromethane, which is just methane with a single substituent group where chlorine has replaced hydrogen. And that's what will happen if the methane is in excess. But if the chlorine's in excess, then it's possible for multiple substitutions to happen, all the way up to tetrachloromethane. So tetra means 4, like a tetrahedron, and therefore this is methane that has 4 chlorine groups. The mechanism for this reaction is free radical substitution. In other words, that species with the unpaired electron is going to come in and take the place of one of the hydrogens in this methane. So there are 3 parts to this reaction. There are going to be slightly more than 3 equations, but basically we're breaking the whole reaction down into 3 bits. So the first part is called initiation. Initiation means starting the thing going. So we're going to make some free radicals. And the way that that happens is that some chlorine molecules are going to break apart homolytically, so that means that both of the atoms in the bond are taking the same number of electrons, so they're both going to get 1 electron from that single covalent bond, and therefore they're actually going to be free radicals. They're going to have this unpaired electron. Now, in order for that to happen, we need some UV light, and this is going to provide the energy to break that covalent bond in the chlorine molecule to form these chlorine free radicals. Now, this isn't going to happen to every single molecule. Some of the chlorine will not react and it will stay as chlorine molecules, but some of it will break down to make these free radicals. The next step is called propagation, and this is actually going to have 2 different equations that we need to know. You might have heard the word propagation outside of chemistry, either in gardening, where we talk about propagating plants when you're making new little plants and spreading them out, or in terms of an idea being propagated, if you share it with someone else and it kind of goes on and goes further and further. Because this reaction is not just one and done, it can continue happening and continue happening until eventually the termination happens. So there are 2 parts to it. In the first part of the propagation reaction, a methane molecule is going to react with the chlorine free radical. And basically that chlorine free radical is going to pick up a hydrogen, and we're going to be left with a methyl free radical. So it's methyl rather than methane. We've ripped off a hydrogen which has taken an electron with it. So we've basically put together a hydrogen free radical and a chlorine free radical to make hydrogen chloride, and we're left with this methyl free radical. But of course that methyl free radical is also really reactive, and so what's then going to happen is that methyl free radical is going to go on and attack another chlorine molecule. And so this is where we get our chloromethane, and then we have regenerated that chlorine free radical, so the whole process can start again. Even though we haven't quite finished the mechanism yet, you should now be able to answer this question by identifying which one of these 4 is one of our propagation steps. So I'm going to start out by ruling out answer C, because nowhere in our equations did we have any hydrogen free radicals. And then I'm going to have a little think about the fact that we want propagation. So this first step is no good to us. This is actually a termination step, which we'll see in a second. And this second one also is incorrect. So although we have got a chlorine free radical attacking a methane molecule, we don't directly make chloromethane, and we don't leave hydrogen free radicals on their own. So our correct answer is going to be the 4th one. So finally we've got termination, and termination is the end of the reaction. So basically it's going to happen when 2 different free radicals join together to make a neutral molecule where all of the electrons are paired. So we've got 2 different free radicals in this reaction so far. We've got the chlorine free radical and we've got the methyl free radical, and they can join up in any pair in order to terminate the reaction. So we could have a chlorine free radical and a chlorine free radical joining back together to make a chlorine molecule in kind of the reverse of that initiation step. But we could also have two methyl free radicals joining up to make an ethane molecule. Or if we had a chlorine free radical and a methyl free radical joining up, we could also make chloromethane in that way. Time for a quick progress check. Pause the video and make sure that you can answer these three questions. Chlorine reacts with methane by free radical substitution. The three steps are initiation, propagation and termination, and in order for the process to begin, we need UV light. Now, it's not just methane that can be chlorinated. Any alkane could undergo that same process. So say if we were to take a different alkane, we would still start off with the same initiation step because we would still need our chlorine-free radicals produced with UV light. Then the propagation could involve that chlorine-free radical attacking a different alkane. So here we've got propane and we're making a propyl-free radical and still hydrogen chloride. That propyl-free radical would then go on to react with chlorine and attack it, and so we would have chloropropane and a chlorine-free radical. And then again, we've got three possible options for termination. We've got the same chlorine-free radicals joining together to make chlorine molecules that we had before. We've got that alkyl-free radical joining with another one that's the same to make an alkane. So here we've got hexane. And we've also got the chlorine-free radical and the propyl-free radical making chloropropane. I also mentioned that if chlorine is in excess, it's possible for further substitutions to occur. So you could end up with dichloromethane, trichloromethane, or even tetrachloromethane. So again, the initiation process is going to be exactly the same. The UV light is breaking apart the chlorine molecules to make chlorine-free radicals. Then in the propagation steps, we can have that chlorine-free radical attacking the chloromethane that we just made. And this is going to end up with us making dichloromethane and remaking the chlorine-free radical. And then the termination steps, again, we could remake our chlorine molecules, we could join up two of these free radicals that are the same as each other, or we could join up that chloromethyl free radical with a chlorine to make dichloromethane. And then it's possible for this whole thing to go through again, so you could have the chlorine free radical attacking that dichloromethane to make trichloromethane, and then we could have a chlorine radical attacking the trichloromethane to make tetrachloromethane. So one final question to check your understanding before we finish. If we have an excess of chlorine reacting with methane, what will the main products be? Well, straight away we can rule out the bottom answer. That's what we would have if we had an excess of methane rather than an excess of chlorine. We can also rule out B and C because in none of these reactions did we produce hydrogen. So therefore our answer for the excess of chlorine is that we're going to make tetrachloromethane and also hydrogen chloride. Thank you very much for watching, and I hope you are finding these videos useful in your studies of A-level chemistry. If you did find this useful, then don't forget to like and subscribe for more A-level chemistry videos coming soon.